So what is a systems of equations? A system of equations is a set of two or more equations that use the same variables. You can solve systems of equations multiple ways. First, we'll go over how to solve by graphing. You can graph both equations as observed, and the solution is where the equations intersect. You can also solve both equations through elimination. First, get two variables to have the same coefficient but with opposite signs. We will call these additive inverses. Add or subtract everything and solve for the variable. Plug your answer into the equation to solve the other variable. Finally, the final way to solve is by substitution. Solve for one of the variables. Solving the second equation for y is the easiest. Substitute the expression for y into another equation and solve for x. Substitute the value of x into either the equation and solve for y. Now what if there's a line and a parabola as opposed to two lines? There are many solutions to a line and parabola. You can have one solution, no solution, or two separate solutions. To find the solutions, you must find where the line and parabola intersect. Here's the equation for the parabola, and here's the equation for the line. We subtract the line and the parabola to get one equation. From here, we would factor the equation to get the answers. These intersections can be plugged back into the original equation to test if they work. What if we're given two quadratic equations instead of a line and an equation? Here you can observe there are two quadratic equations. We would subtract them against each other and find that the variables, these additive inverses, subtract out. So we have 11x squared equal to 0 left over. Thus the value of x and y is 0 and the intersection is 0. When plugging it back into the equation, you would get that y equals 0. Thus it means it is correct. Now what if, in a system of equations, there are three separate variables, x, y, and z? Here we have an equation, three equations. First we would find the additive inverses and subtract them out. 3y is an additive inverse with negative 3y, so we would subtract it with the first and the second equation, and the second and the third equation to get two separate new equations. From here, we would use elimination once again to solve for the final variable, x equals 5. Then we would plug x equals 5 back into the new equations and get that z equals negative 2. And then from here we can use those two variables to find that y equals 1, and our solution is 5, 1, and negative 2. Now, here's an equation or problem with three variables. John wants to buy something for himself with his pocket money. He has a budget of $105 to spend on $25 t-shirts, $10 CDs, and $5 books. He wants to buy 10 items and wants to buy as many books as t-shirts and CDs combined. From this word problem, we can form three equations: $25 t-shirts, $10 CDs, and $5 books. And here we can find that the 50 items total, or 10 items total, is x plus y plus z, and that the number of books as many t-shirts and CDs as books. From here, we can begin solving the equation. As you can see, x plus y equals z can be plugged into this equation to get two z's as opposed to x plus y plus z. From here we can solve that z equals 5. Then we can plug z back into another equation, the first equation, and get a simpler equation. From here, we will subtract and find additive inverses between the two equations, 1 and 3. To solve, and then we would solve to get x equals 2. X plus y equals 5. 2 plus y equals 5. So y must equal 3. The solution is 2, 3, and 5. Now here are some practice problems. 2x minus 6y equals 18, and x plus 3y equals 9. Solve this by substitution. 3x minus 2y equals 11. 5x plus 4y equals 22. Solve this by elimination. Now you're given two parabolas. Find the intersection between these parabolas. Here's a word problem. Jane is asked to buy some chickens, dogs, and ducks for her farm. The total number of animals she needs to buy is 50. She has a budget of $1,500 to spend on $20 chickens, $50 dogs, and $30 ducks. Additionally, the number of chickens should be equal to that of ducks. How many should each animal should she buy? Finally, solve the following systems of equations for x, y, and z. Here are the answers.